Hi everyone, this is continuation of multiprocessing. We have already seen what is symmetric and what is asymmetric multiprocessing system. Now we are going to see process affinity, load sharing, etc. In this processor affinity, a processor affinity is nothing but if a process migrates from one processor to the another, the contents of the cache must be uh, copied to one processor to the another, which cause the contents of cache to be repopulated because the contents are replicated in more than one processor. Because of this, the cost of data transferring also increases, whereas it causes repopulating of cache, and it is more time consuming because the data is getting carried, and it is of less utilization of the processor because it is working on copying the cache data from one processor to the another processors. Because of this, most symmetric multiprocessing system try to avoid migration of process from one process to another. Instead, it attempts to keep the process running on the same processor. This is known as processor affinity. That is, a process has an affinity for the processes on which it is concurrently running. In simple words, if I want to say, a process which is running on a processor will have an affinity to the process, indicating that it will run only on that individual process, so that all those data will be needed to saved on a same processor cache. If it migrates to the next process only, the cache data also need to be migrated. If it has an affinity to that processor, that indicating that this process will run on this single processor only, then the data caching will get reduced. This is known as processor affinity. In this, there are two basic categories of affinity, that is soft and hard affinity. First one, let us see soft affinity. When an operating system attempts to keep the process running on the same operating system, but it does not guarantee that it will do so. We have a situation is known as soft affinity. In this, the operating system attempts to keep the process in the single processor, but it is possible for a processor to migrate to another processor also. In soft affinity, we can say it can't guarantee there is a possibility of migration of that process from currently running processor to another processor. In contrast, the system which provides hard affinity allows a processor to run on the other processor also, because it can't guarantee, right? But in that situation, the processor specifies a subset of processor in which the current process can run. This is known as hard affinity. For example, if we wanted to say it clearly, what to say, soft affinity is nothing but either it completes the process in that individual processor, or else it leaves to the another processor wide open. That process can run on any number of any processor in that system. But in hard affinity, even though if the process running on the current processor can't be executed by the processor, then that processor suggests few subset of processes in which that process can run, because the memories and access of data can be shared to that subset of processor. For example, if I want to say clearly, what to say, mm, if you are coming to get some assignment submitted or any lab concurrency example, on such a period, if your concerned faculty is not available, you will be getting a suggestion from her, and she will give some suggestions or list few of her co-working faculty to guide you on that project or whatever it is, right? In that situation, she is directing you to a specific person who can handle other than that faculty. That is a subset of faculty who is replacement of that faculty. That is the same way, if a processor can't able to complete the work of a process, then it's forwards and suggests few processes which are capable of completing the process. This is known as hard affinity. This is the architecture which shows the execution of the process. Okay, that is the processor which is not able to execute on that particular process. If it is having an hard affinity and it assigns task to a nearby processor, then the data and cache memory is getting shared between these two processes, right? So if a process run on an individual process, the access will be fast, and if it is referred for a nearby process, then the access will be slow. This is what indicated in this architecture. I think you got a clear idea about the processor affinity, what is soft and hard affinity in this session.